Hi everyone, welcome to the channel Math for me and you. Let's learn maths together. Hello, the topic in this video is linear equations in two variables. First of all, we look what is a linear equation. An equation which can be put in the form ax plus by plus c is equal to 0 is called a linear equation in two variables. What are the variables? X and y. A, b and c. They are three real numbers, any three real numbers. Also, there is a condition that a and b cannot be equal to 0, because if a and b equal 0 means, at the same time if a and b become 0 means the equation reduces to c equals 0. That is not a linear equation in two variables. So we can see the condition a and b both not equal to 0. What is a pair of linear equations? If we consider two equations at the same time, two linear equations at the same time, that's called a pair of linear equations. We can put them number and then understand what is the first linear equation and the second one like that. a1x plus b1y plus c1 equals 0. This is the first linear equation we are considering, and the second one a2x plus b2y plus c2 equals 0. You can see now two equations together we are considering. They are a pair of linear equation in two variables. Consistent and inconsistent equation. What is the meaning consistent and inconsistent equations? First we look inconsistent. Inconsistent means if two equations, pair of linear equations, have no common solution, then we say the given equations are inconsistent if they don't have a common solution. Example, parallel lines. Because we know parallel lines, they don't have a common solution. That's why parallel lines are inconsistent. Then what is consistent? What are consistent pair of equation? Consistent means the opposite. They have at least one solution or more than one solution. If one common solution or infinitely many solutions, then we say the equations are consistent. Example, coincident lines. Because coincident lines, they have infinitely many solutions. So we can write an example as coincident lines. And they have infinitely many solutions. In a pair of linear equations, by comparing the ratios of values of a1 by a2, ratio of a1 and a2, and b1 by b2, ratio of b1 and b2. Also, the ratio of the constants c1 and c2, c1 by c2. Then we get the following results. First of all, if a1 by a2 not equal to b1 by b2, ratio of coefficients of x not equal to ratio of coefficients of y, then we can see the pair of linear equations, they have one common solution. Only one common solution. That means if we draw the graph of these two lines, they will meet at exactly one point. They pass through only one point. And if one solution or more than one solution, we can say the equations are consistent. So in this case, we can say the equations consistent. Next is a1 by a2 equals b1 by b2 and equals c1 by c2. If all the ratios, three ratios are equal, that means a1 by a2 equals b1 by b2 equals c1 by c2. That time the equations, they have many solutions, infinitely many solutions. If the ratio of coefficients of x equals ratio of coefficients of y is equal to the constants ratio, then we can say they have infinitely many solutions. If one solution or more than one solution, then what type of equation? Of course, the equations are consistent. They are consistent equations. Now the third case. If the value of ratios of coefficients of x, that means a1 by a2 is equal to b1 by b2 but not equal to c1 by c2. If this condition comes, then we can say there will be no common solutions. The equations, they don't have a common solution. They will be parallelly going. So we can say if no solution means inconsistent pair of equations. So they are inconsistent. By comparing the ratios, we get all these results. Also, by the same comparison, we can understand parallel lines, what are the relationship between the coefficients, and what are the relationship between the coefficients if two lines intersect at one point, at which condition we could say the lines are coincident lines. Okay, we can look all these things. First condition, a1 by a2 not equal to b1 by b2, and already we have written only one solution. What is the meaning? If we draw the graph of the lines, they meet or intersect at exactly one point. So if this is the relation between the coefficients, then we can say these lines intersect at exactly one point. And of course, solution means they are consistent equations. Next, a1 by a2 equals b1 by b2 equals c1 by c2. Infinitely many solutions means the two lines, they must be coincident lines. And equations, they have solution, that means they are consistent. Okay, third case, a1 by a2 equals b1 by b2 not equal to c1 by c2. No solution. In this case, the lines must be parallel lines because parallel lines never meet. And a1 by a2 not equal to b1 by b2. See what all results we get? Only one solution intersect at one point. If all the ratios are equal, then infinitely many solution and the lines must be coincident lines. And a1 by a2 equals b1 by b2 but not equal to c1 by c2 means no solution, parallel lines. Exercise 3.2 question 2. On comparing the ratios a1 by a2, b1 by b2 and c1 by c2, find out whether the lines representing the following pair of linear equations intersect at one point, are parallel or coincident. See the equations, two equations you can see, pair of linear equations in two variables. By comparing the values of the ratios a1 by a2, b1 by b2 and c1 by c2, we can tell whether the lines are parallel or intersect at one point or coincident. For that we will take a1. a1 means the first line coefficient of x. a2, second line coefficient of x. b1, it is -4. And what is b2? Second equation coefficient of y, it is 6. And c1, 8, the constant, and c2 is -9. So we have marked a1, b1, c1, also a2, b2 and c2. We find first a1 by a2, ratio of coefficients of x, 5/7. There is no common number, so we can keep same like that. After that, b1 by b2, it is -4/6. And negative the value, 4 and 6 cancel, we get 2/3. So we get the value -2/3. Then we can compare this. Here the a1 by a2 not equal to b1 by b2. And c1 by c2 no need to look because the first condition itself satisfying a1 by a2 not equal to b1 by b2. In this case, what type of lines are they? They are intersecting at one point. That means they have only one solution. They meet at one point. We can write the result. They intersect exactly at one point. one meeting point. Intersect means meet. So meet at one point only. And what type of lines? Are they consistent or not? Yes, one solution. So that means they are consistent. If solution means consistent. Okay, second, linear equations in two variables. Second pair. Here we can write A1, B1 and C1. Then we can write A2, second equation, coefficient of x, then B2, coefficient of y, and C2, the constant. Then we are writing the ratio of A1 and A2, A1 by A2. A1 is 9, A2 is 18, 9 over 18. Cancel numerator and denominator by 9, we get 1 over 2. Next we can find what is the value of B1 by B2, equals 3 over 6. 3 and 6 we can cancel by 3. So 3 times 1 and 3 times 2, it is 1 over 2. Next, the constant, their ratio, C1 by C2 is equal to 12 over 24. 12 and 24 we can cancel by 12. So we get again the ratio 1 over 2. See, these three ratios are equal. So what we can write? We can write A1 by A2. Coefficient of x, their ratios, equals B1 by B2, ratio of coefficient of y, equals C1 by C2, ratio of constants. These three ratios are equal. Then what type of lines are they? They are coincident lines with many solutions. Infinitely many solutions. Moreover, they are consistent also. Consider the next pair of linear equations. 6x minus 3y plus 10 equals 0, 2x minus y plus 9 equals 0. We can see what is a1. a1 is coefficient of x in the first equation. b1 is minus 3, negative 3, and c1 is 10. Come to the second equation, then we can see what is a2. a2 is 2. b2 is, it is minus 1 there. So we will consider b2 as negative 1. And c2 is 9. Next we can compare the ratios. First, a1 by a2. That is equal to 6 over 2. Cancel 6 with the 2. Then what answer we get? It is 3. Next we will look what is the ratio b1 by b2. It is minus 3 over minus 1. Minus over minus become positive. 3 over 1 means 3. Next is c1 over c2. c1 is 10 and c2 is 9. Can we cancel? No. So we can keep like that. When we compare the ratios, we get the result. a1 by a2 and b1 by b2 are equals. But it is not equal to c1 by c2. a1 by a2 is equal to b1 by b2. But the ratio is not equal to c1 by c2. Then what we can talk about the lines? The given two lines, they are parallel lines. What is the meaning parallel lines? This means the two lines never meet or they have no common solutions. If no solutions, in that case we can say the lines are inconsistent, because no solution means inconsistent. Here the question we can say the two lines are parallel lines. Hope you understand what we discussed here, and if you feel this a useful video, please like, share and subscribe my channel. See you with more useful videos. Thank you.